Okay, today we're going to be taking a look at PS tools because I need to program my new 9200 UDLS, and I figured I haven't seen too many videos on how to program addressable panels, so I figured I would try to be the most useful. So I'm doing a screen recording here, and I'm going to try to get recordings of what I have to do on the panel and what's going on the panel as time goes on here. So we're just going to start. For starters, when you download PS Tools and install it, which should be pretty simple, the link to that, if I remember, I'm going to put it down in the video description. It's at Fire-Lite.com. You can download PS Tools. So you see I've already got a customer in here. By default, it's blank. So you're going to hit New Customer. You'll also have to excuse this computer might show a little slow because it's actually a virtual machine on my MacBook right now. So it gets a little wonky sometimes. So my name is Zachary, so I'll just leave that in there. It's a 198-point address. We're going to hit save. And yeah, we'll save that information. So now here, we want to create a configuration, right? So we're going to start brand new. I actually have a template saved, but we're going to start brand new so we can get a good idea of what's going on here. So first things first, you'll notice that these are the factory default settings. And right now we have it so the communicator is not enabled, which is exactly what I want. I don't have any purpose for the phone lines. I hear them click on and off sometimes, and I don't know why, but there's no reason to have this enabled at all. And because of that, there's no reason for me to go through here and do anything there. So communicator, just leaving it disabled. So now we got our input and output. We have our relays. So I'm going to leave them as the default: alarm, trouble, and supervisory. You cannot change the trouble relay, but you can go through and change relay 1 and relay 3. So if, for example, you didn't have a reason for having a supervisory signal, you could instead have it be just an AC loss relay. So maybe you get a separate notification just saying that the power's out. Or you could even go as far to say, you know, power's out and you don't want to send any trouble notifications or anything like that in the process. Here you can set up your zones. There's not too much we're going to be doing with that because I don't actually have a purpose for it, but you could set it up so zone 0 is the general alarm, general fire alarm, so that's just going to stay pretty normal, but you could set it up so maybe if you have a tornado or medical alert situation, you could set it up so maybe NAC 4, for example, is going to be your medical alert, and those are all going to be amber strobes, maybe horn strobes, but they're going to be amber and they're going to say alert on it. So that'd be kind of a separate notification circuit, and that's what you would use to run a separate thing. So that might be zone number 1. So maybe you've got a medical alert button. When that button's pressed, it activates medical alert, and that's on zone 1. So only NAC 4 goes on zone 1. Instead of zone 0, so those amber lights only flash on a medical alert and not a general fire alarm, while everything else is still on zone 0, which is a general alarm. But that's a brief explanation of how that works, and you can kind of go through, and I can kind of try to show you a brief explanation of how that works. One thing I know it gets used for as well is a water flow horn strobe that might be on the exterior of a building. You might have that on zone 1. And not zone 0, where you have the water flow switch on both zone 0 and zone 1. So it still causes a full fire alarm and evacuates the entire building when the water is flowing, but that alarm on the outside of the building will only activate if water is flowing, but it won't activate if somebody pulls a pull station or a smoke detector activates. So it's pretty simple. And that's kind of what these zones represent, and you can have it do different things. We don't have an audio message, so we don't need to worry about that. Now, these are the NAC configuration options. So right now, on normal configuration is to have it enabled and silenceable. Something you wouldn't have silenceable might be a strobe circuit if you have strobes that don't do sync. And you might also have, for example, the water flow circuit. You don't want that to be silenceable either, just from a general alarm standpoint. So we're going to have it mapped on zone 0 because that's all we need. So this zone is only going to go off on a general alarm. This NAC is only going to go off on a general alarm. In my case right now, I don't want any auto silence. We're going to do, we can set whatever coding we want. We could do 2-stage 3-minute, 2-stage 5-minute, temporal, California, March, and steady. Temporal is also code 3, and that's actually my favorite. So we're going to set it to temporal. And we're going to do a synced strobe, or there's a synced strobe silenceable. And I believe the silence means that there's no selective silence. I'm actually not positive about that, but I believe so. So what that means, though, even if you just have horns on this circuit, if they're like, say, all wheelock horns, you can code them by selecting sync strobe. And so in my case, I've got wheelock devices hooked up right now. So I'm going to set it to, actually for the video I'm going to be doing next, I'm going to set it to steady, which I actually hate the sound of, but that's fine. It'll do just fine. So that's how you set the coding and the sync. So the horn is set to do steady. It's set up to be a wheelock sync, and that's how it's going to all talk together. Next up, we've got our NAC 2. Now this is currently just hosting a wheelock strobe right now, so I normally want them on temporal, and so we're going to do a sync strobe, and again we're going to set it to be wheelock. Again, this is just going to go off a general alarm because that makes the most sense for me right now. And so NAC 2 is enabled. NAC 2 is silenceable, so if I replace that strobe, I just have one strobe there. If I replace it with a horn strobe, then we're going to have a silenceable circuit where the strobe will keep flashing. And we're going to do the same things for NACs 3 and 4, and I don't really have a specific setting for these right now. So for my example I gave, though, if we want a NAC 3 only to go off on a specific event, we might say that it's connected to zone 1. Maybe it's just a standard bell or something, and that's on zone 1, and we could say that another module we put on here, maybe a tornado alert or medical alert, might be the zone 1 only, so it won't cause a full fire, but it will do an evac of the building or mass notification of the building. So that's how you set that up to only go off on a specific event, and you'd put the module or maybe a detector, probably more than likely a module, on mapped to that zone only. So we can just kind of hit next through these right now because I don't have a purpose for that. Now, general system settings. That is a great question. This needs to be changed at the panel because my devices, actually, I've got a lot of the older clip modules around, so I'm going to need to change that at the panel. I can't change it here, but that's what needs to be done. I'm not going to have a trouble reminder enabled. AC loss delay, 2 hours is fine. We're not going to do any pre-signal. We could water flow up to, slow down the water flow up to 90 seconds. So if you've got a water flow switch that doesn't delay itself automatically, then you would set this as the slowdown, and that'll help prevent false alarms. But most water flow switches you see in the field actually have that delay built into them themselves, so when water's actually flowing, it slowly starts going down to hit the micro switch that's inside of it. So we're not going to worry about most of this stuff too much. We do have daylight savings time. which is important. We I guess have a PC installed, but not necessarily. So this here is where you would set up a printer if you had a printer. In this case, we don't, and I'm not too worried about that. And because we don't have a printer, we don't need to worry about this. Here in the States, we got daylight savings time. We need to worry about that. So those are all fine. I'm going to set the banner. Now this is what you see on the display. Instead of system normal, it would just say whatever you want it to say. So in my case, I'm going to do Fleck Family House. And I think I can actually put a space before that. I think a space after that, and that's it. So that's perfect. And then I'm just going to put a bunch of dashes in down here at the bottom, and it'll just look a little nicer. But in the real world, you'd more than likely have the name of the building followed by the address of the building. Because I don't have any purpose of putting my address in the video, I'm not going to do that. So, optional modules, you can have any kind of enunciators or anything. This is where you would set that up. I'm not going to worry about that. Don't have a reason for it. If you had a UDACT, enunciators or anything, I don't have any, so I'm just going to skip over it, but this is where you would go through and provision those. The enunciator bus, we just have it disabled because, again, I don't have an enunciator, but you could enable it, go through and set it up to be whatever you want it to be, and you're good to go. Again, not doing anything with the enunciator bus, so we can actually skip this whole thing. Now we get into adding devices. So I have one detector, and we're going to go ahead and add a device. Because it's 9200 UDLS, it's only got one loop. And so we're going to go through, and this is device 10. So I have it set up so my detectors start at between 10 and 19. Modules are 20 to 29, and devices are 1 to, or pull stations are 1 to 9. So, because I don't plan on having 9 pull stations as of now, this system works fine. If I need to make adjustments to my system later, I will. But right now, we just have a smoke photo. And we're going to give it a name down here. And it is a, or it's in basement storage room. We're just in basement storage. I guess I can't put that in there either. Basement storage is fine. I could enable pre-signal if I want to. So it, if it starts having an issue, the panel will let me know beforehand, before it goes into a full alarm. It doesn't need any silenceable or anything, which is why that's grayed out. It's on zone 0, general alarm. That's fine. It's walk testable. We could do verification, which might not be a bad thing for a smoke alarm, but I'm going to leave it as the defaults for now. So we got basement storage. Okay. And now we've added that device into our programming. Next up, we've got modules. So that's the only detector I have. The rest of them are all modules because it's pull stations, a control module, and a few mini mods. So here we're going to add a few pull stations. We've got 2 pull stations. This is address 1. It's multiple devices. There's 2 devices. And they're both pull stations. So it says that right there, which is nice and easy. The first one is number 1 is by FACP. So it'll pop up on the panel. It'll say pull station alarm by FACP, fire alarm control panel. Again, walk testable, device enabled. This is all very simple. We're just going to leave it as that. and I didn't want it to be both labeled by FACP, so we're going to change this one. So it did put it in programming, and it is a pull station. And this other module is by window exit. So because we're in a basement, we have window wells, and I'm counting that as an emergency exit, I guess. Next up, I've got a control module. So we're going to start with that, and that is number, what is it? Let's take a look. It is number 20. It's sitting right here by me, and I apparently don't know how to read numbers. So, number 20. And that is our control. And you can see there's a lot here, so I could set it up to do a lot of things. But it's just a control. So we could set it up to be resettable power. So if maybe you had a door holder or something, you could wire it up through there, and you'd have to get a 24-volt power source going to it for it to put that power out. But right now it actually does nothing, a whole lot of nothing. But so I'm just going to say we're going to say just control by FACP. So nothing too fancy we have to do here, and this is fine. So we could mark it silenceable. By default it actually is when I programmed it in the panel, but we're going to leave it as non-silenceable for now, and that is basically what we have here. So again, very simple and done. I added a heat detector, and it's a conventional heat detector for now, so that's why we have to put it in modules, because it's designed so when the heat detector activates, it causes a short, and the module goes off. So that is device number 11. And somewhere in here we should see, well, there's heat detector, but I thought there was, maybe this is only in the panel. In the panel it says you know, heat conventional, but I don't see anything that says conventional in here. So there's a lot of options. Could make it do so many different things, but we're just going to do heat detector. And this one is above water heater. The idea is that the hot water, if it were to go shooting out ever, or, you know, the system catches on fire, it's near the furnace too, so if any of these catch on fire, that should trip the heat detector. So we're going to say OK. And we're good to go. So those are all the devices I think I have out in the field right now. I've got 2 pulse stations, a heat detector, a control module, and the smoke detector is over here. So here's the thing that's kind of confusing about these panels. When you've got a conventional, or an addressable detector, that actually shows up as detectors, where if you have anything conventional, you have to put it on a module. Very confusing, but that's okay. So we, of course, could do a simulation. It's going to be pretty boring because there's nothing crazy. So if we start simulation, you'll see it enables the control module, which is hooked up to do nothing. It will enable all the NACs, also won't do anything, or it'll flash the strobe and sound the horn. Same for all of these modules, except for this one. This one is the control module, so this just says that these devices will activate the control module, and you can see what happens with the NACs too. All right, so it's a cool little simulation. You can actually see a graphical view of what we got going on. So we've got device 10 as a smoke photo. We have device 1 and 2 as pulse stations, control module, the heat detector, and the control module. So that's kind of how that works. I should have set this up so this was 21. but I don't really want to pull everything down and reset it, so that's okay. We're just going to go with this, because I guess this should have been 11. That's fine. It's fine. My system made sense once in my head. So now, that is basically how you would write the program. And we're just going to turn to main screen here. And we're going to say yes, save the configuration. All right. So now we get to take a look, and it's got save configuration. So we don't need to configure it anymore. What we need to do is upload and download. And so this is where we get to connect to the panel. So we're going to give a little tutorial here, and this is where I need to get up and also record the panel as I'm doing this. So we're going to do connection settings first. So for me, I'm actually using USB. Awesome. Because this is a virtual machine, I think I'm not off to a good start. So let me go ahead and pause the video here and take a look at what I'm doing wrong. Okay, so I just needed to enable the USB port in the virtual machine. So that's totally okay. It sees it now, and we're totally fine. So, addressable panel, got it, 9200 UDLS. So those are our connection settings, very simple. We're going to go to upload and download. Now, right now, we could pull this is confusing, because it's got upload from panel and download to panel. So upload from the panel is actually taking data from the panel and putting it onto the computer, where download to the panel is taking it from the computer and putting it onto the panel. So you could back up everything if you want to, or you could not. Normally, if you were doing a panel replacement, you would pull everything from the panel that's being defective and restore it onto the new board very quickly this way. Since I'm not pulling anything from the panel, I want to start by connecting to the panel. But, okay, so we're connected now. And I don't have remote downloads enabled yet, so I'll have to show you how we're doing that. But I guess I should show you how I'm connected to the panel. We have a USB cable that runs from my computer, and that's running just up into the panel. There's another way you can do this on some other adjustable panels, where there is a port up here that you would connect a serial cable to, and you can do it that way. I've got NAC 1 off so my horn doesn't go off while I do this. So now that we're connected to the panel, there's some things we can do before we start downloading information to and from the panel. So for starters, I think we can pull any information we want from the panel right now, but I don't really care to do that. We could do a manual evac, I believe, which I don't have my download password yet, so I think that's it. There we go. So here's our manual evac. And so this is, we could also, you can hear the panel beeping, but I can do a treble silence and type in my code again. And so my code is something that I set up when I set up the system here, or the PS tools initially. So very simple to do, and we're going to restore the evac. And again, it wants me to type in my code each time. It's very simple. And there we go. Okay, so now, my knees. Pretty straightforward. We've done that. So we could go through and do some more stuff and kind of get a good idea of what's going on. But for now, we want to download information to the panel. Now, in order to do this, I'm going to need to kind of show you what I'm doing at the panel. So in order to download information from the panel, we need to go into programming mode and hit remote download, and the default code should be a bunch of zeros. And we want to accept download. Okay. So we're going to accept downloads, and here, back on the computer, we're going to just all configuration data, download to the panel, type in my code again. Oops. And it's downloading everything now. Okay, so I kind of sped through the process just a little bit, but it really only took like a minute to go through here. So now, now that that's done, we can disconnect from the panel. And back at the panel, you'll see now that it recognizes that we're disconnecting, and it's going to try to restart here. So now it's going to just take a minute to do this. But I do have one issue, and that's that my programming is trying to use the Lightspeed interface. However, I only have a few Lightspeed devices, but I have two mini mods right now that are using the older clip interface, so I need to go in and change that once the panel resets here. Alright, so the panel just reset, but what it doesn't know yet is that I have some issues and I need to change the clip settings. So I believe that is under loop setup. Oh, it kept it as clip. Interesting. Almost makes me wonder if it didn't save correctly, but I don't know. Alright, back to it here. We're going to connect to the panel again because I did not get a recording of how to set the time. So I want to set the date and time. So we're going to connect back up to the panel, and we're connected to the panel now. So we're just going to download to the panel date and time. And download a date and time. It's 1:34:41. Okay. Alright. So now that information is up to date. The panel now says the right time, and everything is good to go. So besides the NAC 1 being open, we should have everything in here. And at the panel now, we can go through and take a look at the read status of a system point detector. And we're going to start with 010. Alright, you'll have to excuse the water running in the background, but so we got a read status of 010, and it says the name, basement storage, and that's what we uploaded there. And we can go back out to a module and enter 001. So Pulse Station by FACP, that's what I want. Sorry, and we're going to scroll through by window exit, above water heater, and control by FACP. So again, we'll start cycling back through. So those are all the devices I have. Those are all the devices I labeled. So now we need to make the system be happy in order to see the custom banner we created. So for now, put that on there so it sees the resistor, and you'll see the custom label. It says Fleck Family House with a bunch of dashes underneath. And there's the proper date and time, and we're good to go. Alright guys, that ends the video today. It was just a brief overview of how to kind of program a panel using PS tools. Now I need to put this reminder out there and just say it. You should only be doing this if you either A, actually know what you're doing, or B, you're doing this on your own panel like I did. Because this panel is not actually being used for any actual life safety. We have regular smoke detectors in my house for that, and I want to make it very clear that everything needs to continue to work the way it is supposed to work. So if you don't actually know what you're doing, please don't do this on a real panel, and I cannot be held liable for that. So just want to toss that out there. But if you enjoyed the video, leave a like. I hope it was a good kind of overview of how to use PS tools to program a panel, and I hope I did a good job. I tried. So everything seems to be working, and everything seems to be doing just fine. So that ends the video for today.